Hello, everybody. It's 2:18 p.m. Central Time on the 1st of August, 2023. It's been 6 days since my last update. Haven't done any real live talking since then. Few little jump-ons to the Twitch stream, but let's just go ahead and turn on a display capture. We're hitting record. Going to get this out on YouTube. Full earthquake update, and we do have a spread taking place. We are 6 days in on the 7-day forecast, and we are starting to see the spread that we were expecting. And first of all, on day one of the forecast, we saw a big earthquake take place right here up to 6.8. They downgraded it to 6.4. However, our shallower, larger earthquake took place next to New Caledonia first, and then we had to wait the rest of the week. Here we are today, and finally we started to see movement here in the middle, in between all of our deep earthquakes from the past several days, which are raised high off the planet, in case you don't know about the deep earthquakes. So here, sandwiched in between the sets of deeps, we now start to see movement at Papua New Guinea. And opposite side, all the way down here, yesterday, you can see it marked in pink from yesterday's quakes, a stepping stone path of the same sized earthquakes going down and across over to the South Sandwich Islands. They're all about the same size, 5.0, 5.1, 5.2, right down to the tail end down here. Tail end down here where? Well, let's just get a USGS map open so you can see what I'm talking about. Here are the plate boundaries as referenced by the USGS, and I'm not going to dispute the plate boundaries. This is something I use regularly. We go down and across and over to the South Sandwich Islands here on the far right side of Antarctica, and you can see the stepping stone path of the plate boundary, and that matches this perfectly, going down and around and over as we would expect. See how it says travels underneath. When we get a big push that comes in from over here, or over here on the stair-step plate boundary, it goes down and around and underneath, comes back up at the tip. And that's exactly what we're seeing happen now. The only thing missing now is our large earthquake that we're looking for. Tomorrow is the last day of the watch. I'm looking for this to go a magnitude and a half higher. So upper 6, low 7. Same for over here, and make note of the magnitudes. 5.0, 5.1, 5.2, 5.0, 5.1, 5.2. In both directions, going out both ways from the center where the push came up to begin with 6 days ago. So let's recap. 6 days ago, or 7 days ago, I issued my warning, and then the next day, we saw a shallower, larger earthquake take place right next to the deep earthquake. Then a spread took place over the last several days, going out in both directions, now resulting in series of the same-sized earthquakes on both sides of the plate. This is just where we're starting, because we also go up to the north and we take a step up. We're at 5s across the board as expected. So we took a step up across the board. We were at 4s, and now we're all at the mid to upper 5 level. So up here at Taiwan, North Philippines, 4.9, 4.8, and then going up as high as 5.4 and 5.5. This matters because over to the west, 5.5 over to the west just struck today. I'll show you where it struck to the west in a second, but we have other 5.5s and 5.6s to talk about. Up here to the north at Kamchatka, for instance. And then if you take all the activity in the middle, add it together, also equals 5.5 to 5.6, but it's 5.0, 5.1, 5.2, just like all the others. So let's recap one more time. I know there's a lot to take in. We have the same sized earthquake spreading out on both sides of the plate, going down and across over to South Sandwich and over to Papua New Guinea. Then we have 5.5, 5.6, 5.5, 5.6, greater activity spreading out over to the west. So over to the west of what? And over to the north of what? Indo-Australian plate, where we had activity come up from down below it first 6 days ago. So deep earthquakes, shallower, larger earthquakes spreading out along the perimeter of the plates, reaching as far north up into the Aleutian Island chain, reaching as far east yesterday all the way to the South Sandwich, and reaching as far west of the Indo-Australian all the way out to the Red Sea over at Ethiopia. I would just call this the Red Sea because that's the plate boundary where we watch for this to go. All right, so it's the same sized activity going out in all directions, and the span is going from one side of the planet to the other. The only thing missing now is the stepping stone path of 5.5s to 5.6s to reach over to the United States and Canada, where tomorrow my warning expires here for a 6.5. You'll notice there's no earthquake activity reported at all from the USGS, Geophone Potsdam, or anybody. Now, the Canadians are reporting small earthquakes, zeros and ones, but it's gone completely quiet, and it's been completely quiet across the whole area where I have the warning going. So, I don't know, guys. Look, we're getting down to the last day, and we start moving here. We start moving here, and these are the three spots we're watching. And we're now seeing activity go up to the north. On this side, the red line, plate boundary on the north side of the Pacific. Hold on. Let me get it on the screen here, first of all, so you can see it. Up here, we are now moving, and this is the earthquake I've clicked on marked in blue. That's the 5.6 there. We're looking for a 6.5 here at Vancouver Island, just off the coast, right at the north side of the Juan de Fuca. Looking for a 7 or something close to it to strike here at Papua New Guinea. And we're looking for a 7 to strike all the way down here at the South Sandwich Islands. So far, all we've seen is a 6.8 next to the deep earthquake. Big earthquake-wise, I mean. Okay, let's go over to the west and talk about Europe. Take a look. Turkey started to move. Now, this is interesting. We need to go look up the earthquake epicenter because we actually have something at the epicenter that's worth looking up, I think. Well, now, I don't know if I'm going to get it from these coordinates. We might have to get them from the USGS. Bum, bum, bum. Let's see if it comes up this way. It works. What do you know? All right. No, it doesn't work. Or does it work? Does it work? Doesn't work. That's not even close. Okay, let's get the coordinates from USGS. Not even close. Yeah, normally you got to put in a negative and a north and an east into there. It was worth trying. It took us somewhere into the Mideast somewhere, though. Close. All right, let's go take a look. There we are, going into Turkey. Turn on all my borders and places. I'm going to back it out ever so slightly. Now, you'll notice there's several sets of high-voltage power lines, which are here. Now, these are the transmission lines. These aren't just the kind that would go to somebody's house. Now, take a look at this. This is pretty interesting. What is all this out here? What do you make of this? That's pretty darn interesting. I don't know what we're looking at there. It might be a method of farming. However, the high voltage power lines going through the area cannot be dismissed. Now, I turned on my borders and places because I told you there's something here. Look at this. The Karapinar Field, Karapinar. The basaltic Karapinar, I'm probably butchering the way that's pronounced, volcanic field is comprised of 5 cinder cones, 2 lava fields, and several explosion craters. Mars, located along the southwest and northeast line along the Konya Ergli plain of southwest of the, I'm not even going to try to pronounce these words. Okay, stratovolcano. All right, so it's big. It's a huge volcanic field right here next to it. You cannot ignore it when it's marked as a noteworthy Smithsonian volcanic field where we have spatter cones and all that good stuff. Mars and craters and all of this. This is the more ancient. Look how big these are. So these are big. I mean, it's not like it's just some little small spatter cone. We're on the side of a volcanic field. And we get over here and we're on the side of a set of high voltage power lines. Now, what do the power lines have to do with it? We're talking about very low frequency. We're talking about a vibrating wave, electrical, going through the plate. And what's there, right alongside of here, is the plate boundary, where we previously had our breaks down here at the fold in the plate boundary that goes down into the African plate. This is where the big earthquake happened several months ago. But then, after it happened, a series of earthquakes spread over to the west, heading over towards these volcanoes. And which one was it, guys? Do you remember which one it was? I have to go back into memory here. It spread from over here to, I want to say it was Hassan Daji, maybe? It was one of these two right here. It was definitely one of these two, where the earthquake spread over to here, and I made a video on it. And that's where we kind of fizzled out That's where the break kind of died out, if you will, several months ago. The wave then resumed, taking the path of the red line, going back down across Crete, back up into Italy, and out across Europe as normal, and that's what's been taking place ever since. But now here we are, we're moving along the high voltage power lines where there's very low frequency in the power lines, there's very low frequency down in the earth. And when you get a mix of the two, all of a sudden you start seeing earthquakes break out alongside of the power lines. As the wave is saturating the area, the wave is passing through this area. The seismic wave down in the plate, the electrically induced VLF, ultra low frequency, or extremely low frequency actually, going through the plate, and then we get very low frequency up above it, and where the two cross electromagnetically in the plate, you tend to see earthquakes next to the power lines and the stations which generate the power to begin with, whether they're nuclear or coal or natural gas or solar or wind. We see it at all of them. Hydroelectric. Once we get over into Europe, I have to talk about earthquakes you can't really see on the feed right now, which is a series of 4s took place in Croatia. Now that's a magnitude under what I was looking for. I was looking for 5. Instead, we got 4s. Now we got multiple earthquakes, including this 3.9 that you see on the screen here now, and it really is in Croatia. We issued our warning east of Italy in the Adriatic Sea, as far south as Bosnia, as far north as Croatia. I mentioned Croatia like 3 times in the update, and Croatia got hit. Now again, it's a magnitude under what we're looking for, which means there's still a missing magnitude to add in out there, and we have a new 5 that's adding into this. So think of it like this. A wave came in. We were looking for this to happen. A wave came in, went up into Italy, broke at Croatia, 4 and several 3s. But we're looking for a 5 to break there because 5s are going to cross all of this. The wave equal to 5s is going to cross all of this. So far, 4s broke up on the northeast side of Italy. I'm looking for this to take the next magnitude up still. But we have to shift the area of warning now that Croatia has been hit. We have to find the halfway point between Croatia and the new 5 down in Turkey. It's pretty easy. We go down around the bend of the plate. What's the halfway point between Croatia and this orange dot if we go around the bend of the plate and take that as our line to divide in half? Well, it puts us somewhere right in here, doesn't it? Now, this is right where the two plate boundaries meet. This is the Ionia range. Ionia, Greece, right next to Italy, right here. Let me zoom in and show it to you. See where it says Albania, Greece, border region? Right in here is where we have to watch now for the new mid-range 5 to take place. Up to mid-range 5. We also have to watch for, now I have to issue a new warning, for a mid-range 5 to strike up here on the north side of India, or we have to warn everybody from India all the way up into Afghanistan, across Kashmir, over to the west in Pakistan. Now, look, this is 5.5, so it's not huge right now, at least not what I see happening, but it's all in the mid-range 5 level, which is enough to cause damage on mountaintop villages. You guys can get the warnings out to the people in the area. The simple way to look at this, simple way to put it, is that if this was a 2-arm scale, on one side we have a bunch of 5s, and on the other side we have a bunch of 5s. And you are balanced in the middle on this. If this was our balance point, if you were thinking of it like a 2-arm scale, where this was weight on one side and weight on the other, and the accumulation point in the middle for the weight would be in the middle where it's balancing, right? But this is a wave that's going to cross the whole area. But think of it in the same way, that the middle point is under stress from the standing wave, and it's going to accumulate there and break there. And the size of the wave is 5.5 on both sides, so something bigger than 5.5 should break in the middle. The combination of the two. Again, if this was weight, the combination of both amounts on the middle would be the total amount of weight divided between the two, right? I know it's a weird way to think of earthquakes, but you got to think outside of the box, guys. What can I say? That's what a 104 IQ will get you right here, guys. Real quality. It could have said 140 or 401. I don't know. It depends on what time of day it is. Anyway, let's go over to the United States, where we do have to talk about a few things. But, one other thing, before we get into the United States, Central America started to move pretty significantly. all in the mid-range 4 level, and then, check it out, 5.5 to 5.6. Well, now they have it at 5.7, but it was 5.5. Wait, hold on. They might still have it at 5. There it is. USGS has it at 5.6. So just like all the others around the rest of the plate, this time off the coast of Mexico, off the coast of Costa Rica and Central America, 5.6 as well. What does that prove? It proves that it's the same sized activity going out across the whole planet, basically. Not just basically. It's down to the same point on all sides. Up in Alaska, over to the west, all the way in the West Pacific, all the way to the east over here in Central America, and all the way down to the south, down in South Sandwich. So let's get the older earthquakes out of there. Those are marked in pink, and here's what hit today. Now, this one caught my attention. You'll see it. It's raised somewhat higher off the planet here. It's pretty interesting. See how it says 252 kilometers? That's depth, right? I don't know, guys. I don't know. I clicked on the quake, and it says 18.4 kilometers. I don't know. Something's not right. First of all, we hardly ever get deep earthquakes here. Where? Let me show you on the plate boundary map. Here off the coast of Mexico, or just along the south part of the Gulf of California. Deep earthquake reported there, but when you click on it, I don't know, again, it says 18 kilometers deep. But the previous earthquake information on this says 252. Previously, when I clicked on it, it said 380. But when you clicked on this and went to the Mexican agency, it said that it was 380 kilometers away from Cabo, Mexico. Like it was taking the distance and putting it into the depth. But only on this quake, all the rest are fine. But now when you click on it, they've changed the magnitude, they've changed the depth, but 252 is not showing up anywhere. Do you see 252 anywhere in the numbers here? Like, it couldn't even be a translation error on the quake, could it? Oh, it's a different quake. Hold on. No wonder. There it is. See how it says 252 kilometers to southwest of Puerto Vallarta? And then it has a depth of 10 kilometers? See how it says 252 is the depth? It's taking the depth on this quake, this one only, or it's taking the distance and putting it as the depth. I've never seen this happen. It would be the first deep earthquake that we've ever had here. It's rare. So I think it's a mistake. That's what I think it is. Maybe somebody typed it in wrong. Maybe it got entered in wrong. Who knows? But the Mexican feed is definitely reliable. I mean, I'll look at all the rest of the quakes. And we've already checked all of the rest. You can see 10 kilometers. Shows 10 kilometers. This one, 39 kilometers. Shows 39 kilometers. This one, 252. Click on it. Says 18. We got a problem. Houston, we have a problem there. Along the plate boundary. So, is it a real earthquake or is it a mistake? A misquake? If it's a misquake, we will not have a shallower, larger earthquake. If it's a real quake, we will have a shallower, larger earthquake somewhere in Southern California, or the Gulf of California, just south of California, all the way down south of the deep quake towards Central America and El Salvador. So watch from El Salvador to Southern California for a shallower, larger quake than 4.2. How much larger? I would look for about a magnitude larger. That puts us into the 5 range. It's enough to knock things off shelves. If it strikes in Southern California, it'll get everybody's attention. Remember when the news anchor guy dove under his desk when the 5 hit live? They were on live, and the news anchor gets this look on his face, and it's a meme, actually. No, okay, anyway. Now, let's go and look in the United States, lower 48, and Hawaii. So I mentioned there's 5.6s coming across to the north, up in Alaska. There's also volcanic activity, which I have not even mentioned. There's some volcanic activity. I did not plan it this way. I had this up earlier. I meant to close it, but I'm glad you get to see it live. This is my own meme, if you will. Yeah, I made this myself. Isn't that great? I just lost lost track of whatever I was doing. I was coming over to check. Oh, the Volcanic Ash Advisory Center. That's right. Speaking of climate change, right? Okay, so we have a few that are on the list that aren't normally on the list, and they don't normally put off large blast. This one, 10,000 feet, not huge, Ulawan in Papua New Guinea. That's right next to where all the seismic activity just started to pick up. Same with Mayon, south of the seismic activity at Philippines. Sanjay in Ecuador, regular eruptor. Sabancay in Peru, regular eruptor. Fuego in Guatemala, regular eruptor. We're talking about regulars on the list. Nevado del Ruiz in Colombia is diminished, but it went earlier today. Let's see. Who else is on the list? Is there anybody else worth mentioning? I don't see any large blast or eruptive activity yet, and that's good. Now, the number of volcanoes on the list is low. Let's just get that right off the bat. That's low. So we normally see a greater amount of volcanoes, number of volcanoes, and greater blasts. 20 and 30,000 foot can happen regularly. Those are all like 5,000, 10,000 foot high blasts. They're all small right now, but don't let that fool you. Whenever we see a lull in volcanic and we get a bunch of deep earthquakes like what we're seeing now, it's usually followed by volcanic activity that's significant. Now, I don't forecast volcanoes, so I don't get into that, but if we have a volcano in the middle of an area that's warned, and it goes live, or it comes back on the list with volcanic ash advisories that are 10,000 feet, and the volcano's right in here, right next to where all our seismic's taking place, I make note of it. So, let's recap before we get into the United States lower 48. Volcanoes are low. Okay? That being said, the seismic activity in the United States is pretty much happening at volcanic locations all along the West Coast, going as far east as Montana and going as far south as the California-Nevada border. And that's no exaggeration. I can show you the earthquake locations. We can look them up and go see where they're at. But starting up here in the Northwest, I would like everybody to see the number of earthquakes has actually started to pick back up just a little bit. If this was the roll of a drum, the snare drum has just started to be rolled a little bit faster with the drum roll as we go into Yellowstone Park. Now, there's also something going on right up here, right in the middle of where all these earthquakes are taking place. And I got to open up a weather site that we use, College of DuPage. If you want to follow along, you click on Weather Analysis Tools, Satellite, and Radar. And what we're going to do is we're going to go look at the fires. Now, not up in Canada. These are the fires here in the United States now. Yes, we have a bunch of fires that have broken out in a line northwest to southeast along the edge of the North American Craton in Montana and Idaho and over along the edge of the plate over in Oregon. So let's go look from last night into today. This is the visible. So these little black dots that you'll see on the screen here, maybe you'll see them, maybe you won't. Those are the fires in infrared. So throughout the day today, oh wait, you can't really see them. Of course. 200 images. If this was just a few clicks back, we'd be able to see it. Okay, well, I guess I'm just going to have to make a video tomorrow on this, and maybe tonight make the video, and so I can record it after sun gets into here. Here we are throughout the day, and you can just start to see the smoke kicking up right now. Let's click on shortwave infrared. See what that shows. Well, again, you'd have to have it full screen to see this. It's really hard to see. The little black dots that are up in here are all the fires. You're not going to see the smoke until the sun shines on the smoke. It's 2:42 in the afternoon. It's like noon there. The sun's shining directly down on top of it. Not going to be visible. Just straight up, not going to be visible. Let's go click on the natural color fire view, see if that shows us anything different. Last night at sunset. Not really helping. All right, okay, I had to check. It's intense. The amount of smoke coming off this, absolutely insane. Right now, doesn't look like much. You have to take my word for it. What's there? Let's go over and show you on Google Earth. Yellowstone. Yellowstone is right here. The fires north up in Idaho here, and then in a line going northwest to southeast. Of course, the mountains and where the trees are. That's also the Craton Edge. So, the Craton Edge has fires on it going from Idaho up to the north, and far over here in southwest Oregon, right here along the coast. Now, that's right next to the Juan de Fuca fracture zone. Now, hold up, take a look. So we've got fires going here in southwest Oregon and on the edge of the Craton, which the USGS does not show you the Craton at all. I wish they had that on there. A diagram of the Craton. Let me show it to you. Up in the northwest, up in Montana, Idaho, look at the purple part. Look at the rusty brownish part. Or orange or whatever color you want to call that. Tan. So, there it is, right? Edge of the Craton. It's pretty obvious. There's fires going right along it, but that's also where the mountains are, so we can't just say it's the Craton moving. The fires and mountains going in the same direction. I wouldn't be shocked to see it jump from peak to peak and take that shape of northwest to southeast there. If it's elsewhere, we can raise, our eyebrows at it. But hey, I just lost my internet. Wow, it's instantly back on. Did you hear it? Did you hear it? How do you even turn it off and on that quick? How do you shut the internet off and on that quick? That has to be done at the switch. It has to be done at literally at base station. Everybody just got kicked out of the Twitch chat room. Gotta be kidding me, man. I'm live before an audience. The whole audience just got kicked out. That's why it matters. Oh my God. We're back to this. Dude, my internet's been on for freaking 2 weeks straight, no problem. I get on and talk and or a week straight without me talking. Remember, I said at the start of this, I haven't got on and talked much. As soon as I get on, my internet gets shut off. You gotta be kidding me, man. Dude, it's hilarious. All right. Hold on. I'm getting out of order. Order! Order! I said order! Get it? That's my glass gavel. You like that? There's a bunch of hippies' ears just perked up. A bunch of mooches just got online. Okay. Let's go. Are you ready? Speaking of mooches and hippies, let's go up into the northwest, up into Washington and Oregon, and talk about the quakes. Look, by the time I get to talking about the United States, I'm done with doing an update. Let's go look them up and see what's there. Let's start up here in the northwest, up in Seattle. Now, guys, we're looking for a 6.5 earthquake to strike here by tomorrow. I don't know if it's going to hit. If it doesn't hit by tomorrow, I always give myself a day after, just in case Mother Nature is not running on my time schedule or I'm wrong. So I just wait, just in case. There's been many days where we get to the end of the warning and it hits. But if I were to flip a coin on it and say, hey, is it going to hit or not, I would guess not. That being said, look at the ring of earthquakes all the way around the Seattle Fault. There's a series of small earthquakes, nothing to be worried about, going right across the Seattle Fault itself, and a few up in Vancouver Island. I'm looking for Vancouver Island off the coast to get that 6.5. Now, the rest of the quakes, down here, these two clusters, Mount St. Helens, Mount Rainier. I'll pull the quake from in the middle on each. Notice how they don't tell you where it is, right? Like, they don't tell you it's at a volcano because they don't want to worry the grandmas who check the freaking grandpa, sorry. Whatever. The Zoomers. The kids. They don't want to worry the kids. How about they don't want to worry the normies? That's better than normies. They don't want to worry the normal people. The people who get worried when small earthquakes strike next to a volcano that always gets hit with small earthquakes. Now, why does this volcano always get hit with small earthquakes? Well, there's a wave that regularly comes through here that passes over to Yellowstone. As it's passing through, drops off the earthquakes along the way. Same size earthquakes that strike here, strike over at Yellowstone within the day. Down to the south, same thing. This one's at Mount St. Helens. Let's go get the coordinates on this. Amboy, Washington. You'll notice they also don't tell you this one's next to a volcano. I think they should have a little tab. Seriously, I'm not, I know the USGS doesn't care what I think, but, right? Oh, wait, except for except for the tweets they issued about me, right? Anyway, aside from the USGS caring about me like that, I know they don't care about what I have to say like this, but they should have a tab on here that says significant geologic features nearby. Geothermal, whatever you want to call them. That you can click on it, takes you to the nearest volcano, and the nearest geothermal field, because they're related. It's just, it's not a big deal. It's no big deal. But when you get a series of earthquakes on the side of a volcano, I think every schmo in the world and every researcher would want to know. And you would literally have to be psychic or know the area ahead of time, coordinates-wise, to know this is at St. Helens. Because the way they triangulate it just says 30 kilometers from such and such, Amboy, Washington. But those of us who watch long enough know 30-something kilometers from Amboy is St. Helens. Anyway, there it is, just like Rainier, left side, right on the flank of the volcano as the wave is coming in. Wave is coming in from the northwest, hence we have a series of earthquakes coming in from the northwest, spreading to the southeast. 2 lone quakes over in eastern Washington. I would like to go look this up just to see what resides there. Might not be anything significant at all. It's an explosion. Boom! Let's go take a look and see what's there, shall we? Let's go see this explosion site. Are they doing quarry in there or something? What do you think they're doing? Quarry, right? Uh-oh. Propane tank exploded out back, Dutch. All right, what's here? We got anything else here nearby that we need to see? That again, what are we blowing up out there? Right? It's tannerite and target practice. Anything else? Well, there's the Columbia River right next to it. What else do we have here? These look like high voltage power lines over to the east, but where are they going? And the Columbia River, I thought there was some big power going on there. I don't see any bridges or dams. Oh, hold on. Is that just a bridge? It is, okay. Yeah, not seeing any power generation going on here. You would think they would have it. Okay, an explosion. It is a true blast. Recorded out in the middle of nowhere, out in the woods, next to somebody's house that's about half the size of Kim Jong-un's nukes. Since Kim Jong-un's nukes, the first ones, came in at 2s and 3s. To get a 1.7 there, pretty big blast. Hey, did you hear the disinformation story by some geologist trying to get cred with Taylor Swift? Caused an earthquake, meh. Shh. Freaking liar. Whatever, dude. These people are liars, man. No, Taylor Swift did not cause an earthquake. Unless she got huge all of a sudden, and I mean pushing maximum density. Taylor Swift pushing maximum density all of a sudden caused it. Taylor Swift's so fat, she caused her own earthquake. Okay. That's the only way that's going to happen. Now check it out. We have a series of small earthquakes down here on the south side of this. This is Hanford Nuclear Waste Storage. Speaking of Taylor Swift, nuclear waste storage. This is the place where they put down all the broken down old nuclear reactors after the experimental Manhattan Project stopped. They took all the radiological materials, put them in here. Unfortunately, some got out. Unfortunately, some blew out across the area with small uranium shavings. Now, they decided it would be a great idea to come in here and build these long lasers at the LIGO Gravity Wave Sensing Station is what this place is called. Or it's just called LIGO. But it's a gravity wave sensing station. And the long lasers in here. Now, they have a scaler where the lasers cross. They look for vibrations in the long lasers. Looking for vibrations from gravity waves. Now, it's just chance, guys. It's just chance. I'm telling you, man. I swear. Just chance. I did not build those lasers next to the radiation. Okay, that was my Bill Clinton impersonation. All right, now check it out. This thing's pointed at a right angle at the heaviest elements known to man, stored in caskets in the ground. And they tell us it's just chance that they built it here. That's the biggest load of crap ever, that it's chance. It's not chance. They built that thing at a right angle to the heaviest elements known to man, looking for gravity waves. But not because they're coming from across the universe. They're coming from across the planet over in Russia. You got to get into Lieutenant Colonel Thomas Bearden's talks on detonating nuclear waste by the Russians using scalar waves. And then you understand why they have a scalar detector there, because that's really what it is. A scalar wave detector, which they're using to also detect gravity waves, which scalar waves are gravity waves. Scalar waves are gravity waves that come out of a place where radio waves cross. Scalar waves are, well, they don't even exist in modern terminology. That's a slang term created by Lieutenant Colonel Thomas Bearden to describe the electromagnetic disturbance that happens when you have interferometry, interference of radio waves at a distance, when you cross radio waves at a distance. In his lectures from the 1980s, Soviet Weather Engineering over North America, which I have on my channel if you want to watch, talk about the crossing of the radio waves from two huge transmitters in Russia, where they would cross them over the United States and create these huge disturbances in the early 80s, creating massive weather phenomena. Anyway, and that's why it's there. And the earthquake there. Is it an earthquake? Yeah, it's a quake. It's not an explosion or any kind of man-made thing. So it's a vibration. Oh, hold on. Heard? Braveheart. Heard. Okay. Check it out. We got a new 4.0 earthquake, which just struck off the coast. Out here in the Juan de Fuca. Port Orford, Oregon is what they're calling this place. I'm telling you, man, it's the Juan de Fuca. There it is. New 4.0. That's on top of the other one that was just like the other one. So that's like 3 of them now out there in the area where we were looking for a break to happen last week, and nothing got reported. Now that a new 4 struck out there, I'd look for a new 4 down here in Southern California. Or I'm sorry, Southeast California. I got way sidetracked on this update. I might just chalk it up as being one of my lesser scientific updates and more just a little bit I needed to get on and talk after 6 days of not talking. Let's go down into Oregon and take a look, see what's going on down here in Portland. Oh, it's another explosion. I don't know what's going on, guys. Are you blowing stuff up all the time out there or something? Do you have the most sensitive seismic equipment in the world where you only pick up explosions here and nobody else picks up explosions anywhere else in the world? And why are they only happening out where there's trees? Is this another case of the spontaneous combustus coniferous, the Monsanto GMO tree designed to explode and simulate an earthquake? Yes, spontaneous combustus coniferous is the name. Now, never mind the big high-voltage power lines right next to that. Never mind that. So pay no mind to the big high-voltage power lines. What is this place? Look at that. What is this? Some kind of weird building with walls around it. Oh, shit. Dude. When the New World Order tries to send you a message using earthquakes, the Coffee Creek Correctional Facility. We're across the street from, we got a blast across the street from the Coffee Creek Correctional Facility. See? Oh, another explosion. I'm clicked on the next quake and it's another explosion. Are you kidding me? Dude, this is bizarre. This is bizarre. See, why can't I just do earthquakes? Why does it gotta always get weird? I'm just weird. I'm just weird. It follows me around. There's no doubt about it now. What is this? Luckamute River? The Luckamute River? Okay, man. All right, look. Either somebody seriously... Black Rock? Oh, no, dude. Oh. Oh, no. Look, man, you're all about to get a conspiracy lesson in about 2 seconds, all right? Look, if you go look that up, don't do it. Don't... Whatever you do, for crying out loud, have a normal day for once, you know? Jeez. Let's get the out of here now! Get to the chopper! If it bleeds, we can kill it. Unity, Oregon. All right, Unity. It's an Operation Ivy song. It's the best thing that's going to happen to me today. I'm dating myself. You don't know who Operation Ivy is. So far off the rails so quick. Look, another set of high voltage power lines out in the middle of nowhere. What else is here? That's all there is. Look, they go to a huge trunk of high voltage power lines, splits off 3 ways. What's going on there? You know, where you see this, you got to look for hashtag Tartaria. You have to look for large structures. Large megalithic type structures. Huge, multi-100-mile long structures is what you have to look for when you see stuff like this. Now, we have an earthquake on the side of where the power line split. I don't see anything else here except for more power lines crossing. 1, 2, 3, 4 sets crossing there, and 3 to 4 sets crossing on the north side. I don't see anything else worth mentioning here other than the high voltage power lines right next to where the earthquake is happening. How many is that now? That's a lot. It really is. Let's go look up this next quake in Oregon. Man, I'll tell you what, Black Rock, jeez. Subliminal messaging. Oh, it's right next to Mohawk. That was the other place, the Mohawk. The name of the town there was called Mohawk, in case you don't know about my Mohawk. That's weird. Okay, what else is going on here? What? Wagon Tire. Oh! We're at Silver Creek Volcanic Center. The volcanic field covers 1,600 square kilometers. We're right in the center of it. So this one's at a volcanic field. Finally, an earthquake that's not an explosion or next to power lines. Wouldn't that be weird if there were power lines going through the middle of the desert out here, wouldn't you think? Through the middle of the volcanic field? What are these? Looks like somebody's taking the time to scrape out the... Oh, hey! Hey! Hey, look, man. It's another one of my big discoveries. That earthquakes are following where power lines are above the ground. Down on the ground, the earthquake's happening. Up above, power line. Power line containing very low frequency. Earthquake wave down in the plate containing extremely low frequency. Where the two waves combine, the scalar happens, like what I told you at the LIGO gravity wave sensing station. All right. Well, yeah, we're literally right along a set of high voltage power lines out in the middle of the desert. Well, high plains, sorry. High plains. Not desert. Down to the south, down into Nevada, we get into the desert. Let's go down into Nevada and see what's down there at Oro Veda, Nevada. Oro Veda, Nevada. Orovada, Nevada? Which way do you say it? Orovada, Nevada, or Orovada, Nevada? Or Orovada, Nevada? Somebody's messing with me, dude. Somebody's messing with me with these earthquakes today. Is it the universe? Is it God? Jackson Mountains, Bottle Hill Butte, and Pinto Mountain Volcanic Butte. That's where we are? Red Butte, we're right in between all three. Which one do you think is the closest? Bottle Hill Butte. Bottle Hill Butte being the closest. We do have ancient tuftage and some old black basalt on the side. That's about it for that. That doesn't really look like a volcano much. We have a road on the north side. King Lear Peak on the south side. And then the one that stands out is Pinto Mountain. It's mesa'd out, actually, from wind. But, oh yeah. Okay, yeah, you can definitely still see the old lava flow on that. Hold on. Multiple layers. Wow. All right. Interesting. All right, we're on the side of an ancient volcano that was once underwater. Down to the south we go, 2.6. Lovelock, Nevada. Copy and paste just like all the others. Put them in, go look them up. You guys should take the time to do this yourselves if you're bored. You ever sitting around just don't have anything to do? Look up the earthquake coordinates. You'll start finding stuff. Good luck telling people, though. All right, what's this place? Lone Mountain. The Lonely Mountain. Wow, what a... China Mountain and Buffalo Valley. A group of cinder cones and lava flows in Buffalo Valley north of the Oligocene Fish Creek. Is that how you say it? Caldera. Wow, hold on, caldera. Where's the caldera? Mount Moses? Really? There's our cones. Where's the caldera? Oh, this whole thing is the caldera. Is that what it is? Wow. All right. Ancient. Huge. Here's our earthquake epicenter. I'm just wondering, is there anything else out here worth mentioning? A road? Looks like this is for... Wait. Ah, kids. What are you worried about? The geothermal electrical generation station. Think it's related? All the drill points here, collecting steam to take it to the pipeline, to take it to the turbine. Do you think the earthquakes next to the geothermal plant are related to the geothermal plant? Or do you think they're related to the electricity being generated from there and sent out? I'd say both. Let's go into Northern California, get out of Nevada. That's our earthquakes in North Nevada. Let's go over into northwest California. Willow Creek, California. Willow Creek. Paste and search. What's in Willow Creek? Northern California, late July, early August, Willow Creek. Now, I know there's a lot of old trees up here. See where it says Willow Creek? We got Denny, Hoboken, Big Bar. I'm just looking for anything significant out here that might, other than a fault, of course, that might lead us to the quake. Quake's cause. Why did it strike here, of all the places? Trinity River. Where have I heard about this place before? Don't they do something up here? Isn't there something up here? I don't know exactly where it is, though. Anyway. Okay, we're east of Eureka. That's all I could think then. If I can't find any power lines, no volcanoes, no drill points, no nothing there, I would lend it to the being an actual fault zone quake only. Which is pretty rare if you look at all the quakes that I just showed you. The fault zone quakes are kind of rare. The rest are actually happening at volcanoes, next to power stations, and other weird things. Here and there, we get an occasional fault breaking on its own, without any precipitating factor, other than a wave passing through it. What's this? A path out there in the middle of the woods. right? Anything else worth looking at? Oh, well, what's this big line here? Those are high voltage power lines again, but just to the east we have Silver Lake. Just to the south we have Black Butte. And then these are ancient lava flows that are mesa'd out, just like the ones I was showing you just a few minutes ago. Out in the desert, the one that was black and there. It's mesa'd out, but this is an old lava flow. 100% on that. You can follow that back. And the shape on it also tells this. You can see it. It's eroded over time. Goes back up to here. And look what we have. Whole sets, multiple sets, crossing. And again, these are not the kind that go to your house. You can't keep telling, again, if you're going to try to tell me this is chance, that we keep getting outbreaks next to these multiple conjunctions of high voltage power lines, and we're at volcanoes, and they're doing the high voltage power lines alongside of where these spots are on purpose, I think, to collect energy. It's just a guess. That's why the power lines are going over a lot of the megalithic spots and a lot of the volcanoes. That the power company is collecting the power from that high off the ground. I think that somebody found this a long time ago. If you fly a kite at a certain height above the ground, you can actually pick up electricity. It doesn't have to be a thunderstorm. That's the big thing about the discovery of electricity, is that it doesn't have to be thunderstorming outside. No. The worry is that you'll get electrocuted if you get struck by lightning. But that on a regular day with blue sky, if you fly a kite at a certain height, you pick up an electrical charge and bring it down to ground. Anyway, all right. Hey, why aren't we collecting energy that way? It must have something to do with those old Edison aerials. They didn't call them antennas back in the day, right? Yeah. What are those lightning rods on the outside of your house? Oh, it's for stopping lightning from striking your house, is it? That's interesting. Why don't we use them today? Edison aerials. 1908. Go look it up. Let me tell you something. There's a guy whose name is Paul Cook. And I'm going to show you something that you need to go look at. He put out a video a day or two ago. Let's see. It might be this one or this one. I don't know which video it is that he put out. We'd have to go through. It's one of his more recent videos. And he's scrolling through, might be one of his lives. Here it is. Free Electric and Old Books. There's Paul. Cheers, mate. Now, as he's going through this old magazine, he's showing the ads in the magazine. But I noticed something over here on the right-hand side. It was a question and answer that was going back and forth between readers of this magazine in the early 1900s, asking the magazine how to build certain things, and with their question and answers for this aerial transmitter that was being used to talk to each other wirelessly up to 500 miles. Okay? Now, they have in here, in the magazine, I don't know exactly where it is, on the right-hand side, question and answer. They have question and answer for rectifiers. And you have to really know what a rectifier is and to understand what we're talking about here. This is the conversion of radio waves into power. So to pick up a radio station, have it come down the antenna, and instead of coming out your speaker, it produces DC power coming out the other side. These already exist. But NASA claims to have discovered it in 1970-something, the rectification for electricity. But yet, here's Paul in 1908, and they're asking about the rectification in the Q&A on the right-hand side. Which means they had rectifiers installed on houses in 1908. And the guy, one of the questions is, hey, our antenna's up on top of the building, our 5-story building flat. and a kid is using one of them. It's running off the same antenna and going to his house. But it's not coming to mine. Why? And they answer his question. That his device may be the kid's device in the other house may be interfering with his receiving of the electricity. Not just for sending voice communications across a large distance. Okay? Do you see this? Hopefully you saw that. Hopefully you saw all that. I don't know if you saw that or not, but if you did, you did. If you didn't, you didn't. Link to Paul Cook's channel is down below. Why am I taking the time to talk about that? We get back to the quakes. This gets into wireless power going through the plates. This gets into conversion of AC to DC. So all of a sudden we got these power lines and the earthquakes, and we have DC in the ground, and we have AC in the lines. AC is radio waves, but it converts to DC when it goes down into the plate. Yeah, right. Oh, what did I disprove? Well, it just proves that maybe they were using wireless electricity 100 years ago. Kept a secret from us. Somehow it got buried in history and they all went to wired power. I don't know, maybe it had something to do with the earthquakes. All right, let's go down to the south. Go talk about the quakes here along the California-Nevada border. What would you do if I told you the rest of these quakes are at volcanoes? California-Nevada border, all of them. Here, between Lake Tahoe and Pyramid Lake, south of Lake Tahoe, California side of the border, Nevada side of the border, again, California-Nevada side of the border again. All of those are at volcanoes. Do I need to take the time to prove that to you? Can I just gloss over it really quick because we've already gone on too long? And I always show it in every update. Lake Tahoe, Pyramid Lake. In between, large oval shape, giant caldera I had to find on my own. It's lined with volcanoes. Earthquakes are all the way around it. And that's what's going on up here to the north. Up further to the north, we're next to the power lines and Silver Butte volcano. Down to the south, supervolcano here at the California-Nevada border, and over across the border, over in Nevada, Monte Cristo Hills volcanic buttes. Supervolcano there. This is a documented supervolcano, Long Valley Caldera. Across the border, Monte Cristo Hills. I'm just quickly going over it because I don't want to waste all your time here looking up old volcanoes. Series of small earthquakes striking at each, just like up in Washington, guys. Mount St. Helens and Mount Rainier. Yellowstone as well. Oh, Oregon, whatever the name of that one was. I forgot the name of it. Power lines right next to each, right? Down here at the California-Nevada border, it's Yuba Hibi craters. Earthquakes on the north side of Yuba Hibi craters. There they are. Little Hibi. Little Hibi and Yuba Hibi. Little Hibi and Yuba Hibi. Okay. Let's go down to the south. Indian Springs. We're going into a nuke test site. Pulling the coordinates just so you know that not just guessing where we're going here. Series of earthquakes breaking out here. Don't worry, it doesn't mean we're doing nukes here now. There are old volcanoes here as well, but the nuke site, here's Doomtown and Operation Rise Line, Frenchman's Flats, as it's called. The bunkers. And then here, underground sites, just hundreds of them, underground nuke test sites. And we have names on all these. I just like to show them to new viewers, in case you don't know how many there are. U.S. Nuke Operation Belen. Belen. No. Belen. B-E-L-E-N. No way. 97 kilotons. Long story on that, guys. That's a weird name, isn't it? Nuke site there. Over to the east, we have one lone quake far to the east of the nuke site. But where do you see where this comes in next to? You'll wish we had gone back to the nuke sites because this gets a little abnormal, the one over here to the east. Nuke sites right over there in that valley. Here, see where it says Badger Mountain, Range 61, and Area 51. Groom Lake, Area 51 right next to it on the mountain range over to the east. Now, we get over into Utah and you'll see it's a swarm of nothings. A swarm of zeros. Actually, look, it says it's a negative earthquake. A negative earthquake at the surface. So what the computer is really telling us here is that at the surface, they have a black hole generator that's sucking in energy. We better not get too close, otherwise we might get sucked in. Is that what they're trying to tell us? Negative earthquake? Or are these all just zeros and the computer is telling us nothing is happening here? It's a bunch of reports of nothing. That's what the computer is telling us. Dutch, there's nothing happening here. But if that's the case, why is this here? Is this the computer's way of trying to get my attention? AI? Has AI become self-aware? It's like, Dutch, look, I can't tell you because they're putting the censorship on this. But here's this geothermal plant again with this outbreak of earthquakes, a swarm of nothings there. The nothing is coming, and we're not talking about the never-ending story. Let's go down to the south. Down into, where is this? It just says Utah. Whenever they do that, I get suspicious there's something there that they're trying to hide. Let's go see what's going on. Dutch, you're getting paranoid. No, I'm not. Peek out my window. Oh, see Miller Knoll? See this lava flow? First of all, get a load of this volcano. It's covered in trees, old. But look, young lava flows coming out the side. And on the side over here, there's another one. I don't know where it came out from. You can see which way it flowed, though. Lava flow goes over the hills. These are hundreds of feet high, the lava flow, with no trees on it, or hardly any. Look at that. Pretty young in comparison to the volcano it came out of. So what happened here, this old volcano, this old butte, broke open on the side and flowed out. Why? Pressure came into this volcanic field. What's this? Stoker Poker Palace. Stoker's Poker Palace. What? Why is that marked as a historical monument? That's bizarre. You know what's really weird? You know what's really weird about that? This is so weird. That's so strange for this to come up as a... I just ordered for my Dutch Synths operation 100 Toker Pokers. I'm not kidding. With my Dutch Synths logo on them. They're lighter holders, sleeves that have like a little poker on them that bends out the back so you don't have to poke your bowls. I'm not kidding. That's bizarre. That's weird, man. Okay. Like I said, I'm weird, but look. Yeah, there's just some weird shit going on. I'm done. That's it. We're done. Class dismissed. Early dismissal. Tell your parents I said hi. 9-year-old Army out. You gotta be kidding me, man. Bizarro world. That's all I gotta say. Do you have an earthquake plan? Does it even matter? Look, kids, your teachers had a rough last week. I made a big discovery over in Scotland at Loch Ness. Got me in big trouble. I got in big trouble last week for my big discovery. In case you didn't know. Big discovery last week, got in big trouble. Why did I get in big trouble? For finding something in Scotland? At Loch Ness. Frickin' Loch Ness. Nessie. Do you guys know what I found at Loch Ness? Did you catch it? A giant dragon's head that everybody missed somehow. Nobody knew about this. I got attacked all week for this. People denying it, saying it's not a dragon's head, saying I'm seeing shapes and stuff. And now they come out and say, now the argument has changed. They've now said that everybody knows it's a giant dragon's head at the mouth of Loch Ness. We found the plans for it. So the fort plans for it? Okay, yeah, found it, all right. Anyway, yeah, it's not up for debate anymore. I mean, not that it ever was. It's in the shape of a dragon's head. And here's Loch Ness. And here's the River Ness. Goes right out into the bay. And at the mouth of the bay is the giant serpent head or dragon head or whatever you want to call it. It's a dragon. It's not a serpent. It's got horns. Yeah, got in trouble last week. Been a rough week. Now, here's the question you all must ask yourself. How the hell did everybody in the whole world miss that giant dragon's head at the mouth of Loch Ness for 300 years? And why did everybody get mad at me for finding it? And, well, not everybody, but a whole bunch of people. Why did a whole bunch of people get mad at me and then deny it? Is it just because I found it or something? I don't know. It's weird. So this past week was rough. I was not looking for anything weird to happen in this update. To get stoker pokers, after I order toker pokers, and earthquakes next to all kinds of other weird stuff going on. I'm done. I'm done. The world of the occult revolves around earthquakes. And on that note, you should have an earthquake plan, probably. I'm just guessing, it might be a good idea. Emergency kit 2, the change of clothes, the set of shoes, flashlight, batteries. That's not just for preppers and weirdos anymore, guys. That's for people who are getting evacuated on a regular basis for storms, fires, weather, earthquakes, everything. You need to have it. Change of clothes, set of shoes, flashlight, and batteries. Anything else? Food and water? I don't know. Extra pack of smokes? Don't forget your lighter and your toker poker, you damn hippie. And on that note, I'm going to save this as a video and we're going to put it out. Blemishes and all, uncut and ready to be viewed. This update's not for kids. What is it? PG-13? Did I say the F word during this update? I don't think I did. Pretty sure I didn't. I almost did. So I think it could probably be filed under PG-13. I think you could have your teens watch it and they might. All right. Generation Alpha is where it's all going, guys. God help us. Generation Alpha. Peace out.